All right, we've got another video on factoring by grouping. In this set of examples, we've got three problems we're going to work through. We've got problems that are already in four terms. If you remember, we were factoring quadratics in the other videos, and we kind of break up this linear term into two terms, which would allow us to group it. But the nice thing about this is whenever we have four terms and we're asked to factor, often what we can do is we can just group them from the start. And so if I look at my first two terms, I'm looking for what's in common out of those to factor out or undistribute. And in this case, the coefficient, or the GCF of the coefficients of 4 and 2 is 2. And then the GCF of the variables, x cubed and x squared, is going to be x squared. So whenever I factor that out, I'm going to be left with 2x plus 1. And now let's come over here and work with this on the left. You might be looking at negative 2x minus 1 and saying, well, there's not really anything in common to factor out. But what you want to do is, if this term on the left is a negative, then you can factor out a negative. So let's at least factor out a negative 1. And so negative 2x divided by negative 1 is 2x. And then negative 1 divided by negative 1 is going to be positive 1. And now we know we're doing good because that matches that, and that now becomes our GCF. So I'm going to factor the entire 2x plus 1 binomial out to the front, and that's going to leave us with 2x squared minus 1. So this would be the factored form of this four-term polynomial up here. Let's look at another example. In this one, it looks like we're ready to group as well. So I'm going to group my first two terms, and I see that there's a 7 here, but there's not really a coefficient here, so I can't really factor out a coefficient. So let's just factor out that m. If I factor out the m, I'm left with p squared plus 7. And then if I look at these two terms on the right, now there's no variables in common, but it looks like I can factor a 3 out of both of those. And 3p squared divided by 3 gives us p squared. And 21 divided by 3 gives us 7. So we're doing great because that matches that. That becomes our GCF of this entire thing. So we're just going to take that entire p squared plus 7 and factor it out to the front, leaving us with m plus 3. And that would be the factored form of this four-term polynomial. If you weren't sure, multiply it back out and see what you get. Now, here's our last example, and I made this one a little bit tricky because if we're looking at this and we kind of start it like we did the last problems, I might look at those first two terms and I'm sitting down to work the first two terms, or I'm sitting down to group the last two terms. You're like, well, there's not really anything in common here, and there's not really anything in common here. And so what you got to do is you got to get creative with it. And what I know is that while these first two terms don't have anything in common, I can rewrite these four terms in any order I want. And so there's a couple of different ways to do this, but I'm just going to leave my first term here. But I see this has a y squared in it, but this last term has a y squared in it. So why don't I just rewrite it in this order, ay squared, and then I'll kind of put these two terms over here at the end, plus az minus 2z. So the first thing I just want you to think about is in a problem like this where you're factoring, you might have to reorder the terms first. Because now that I've reordered, I can factor out my GCF. For this first one's going to be y squared, and that leaves us with 2 minus a. And then over here it looks like what's in common is a z, and that leaves us with a minus 2. Which brings us to our second thing I wanted you to kind of think about in this video. Normally we get to this point, this value in the parentheses has matched this value, so we've just factored it out to the front. But that's not the case here. 2 minus a is not the same thing as a minus 2. And so the question is, what can we do? How can we manipulate these to make them match? Because that's kind of what we have to do next. And so what I'm hoping you're thinking is okay, well, if I change the sign of this and made it a negative a, and I change the sign of this and made it a positive 2, negative a plus 2 is really the same thing as 2 minus a. So what I can do here in order to change these signs is let's factor out a negative. Instead of z, let's factor out a negative z. Because that would make this a negative a, and it would make that a positive 2. So let me kind of rewrite what we have so far. We have y squared times 2 minus a minus z. It's a negative a plus 2, but let's just reorder it so that we have consistency. And now we're here, and what's great is by doing that little bit of algebraic manipulation, we now have a common factor that I can factor out to the front, and then we're still left with our y squared minus z. and this would be our factored form of this polynomial. So 2 takeaways I want you to have from this problem. The first is that you might have to reorder your terms, which is exactly what we did here by moving that term to be our second term. Reorder the terms so that there's something in common you can factor out. That's your first thing. And the second thing is you just might have to get a little creative whenever you're factoring out values in your groups. Because when we factored out our values in our groups, we didn't have the matching value in parentheses left. So by factoring out a negative, we got these 2 binomials to match. And it could be factored out to the front.